All right, day one. So just disclaimer, I explained in the previous video, day zero, that this is just a build in public project. Just doing this to learn, taking this course, and as part of the course, we are building a knowledge management system or a knowledge management graph for the students to interact with a model, an open weights model. To ask questions from the transcripts of the course workshops. So with that being said, in the last video I explained the project, the intended project, what we're doing, and kind of the setup and the coding agents and the environment that I'm using. This day one, the goal here is to actually get the model up and running on Modal. We're going to start doing the backend database and that stuff in day 3 tomorrow. So, to be honest, I tried to do this live, but I kind of screwed it up a little bit. I was able to get the actual model Qwen live on Modal really quick, like 30 minutes, but I had no fucking idea how I did it, and I tweaked the code quite a bit, so I kind of had to go back and unpack how it all works. So this is going to be more of a step through that process of unpacking it. It should give you an idea of how to do it though. This is just my way of explaining the abstraction and how it works. So we chose this model for the project. Qwen explained why we chose that model in the last video. And basically what we need this model to be able to ingest or take a prompt, a question from a student about the workshop, but then obviously needs to go off and search a vector database, which we're using Chroma for, and then return responses to the students based on the question. So we're not going to do the database or anything in this. So right now we just want to be able to get Qwen live on Modal and then make sure that it works. And then next week we can build in the vector store. Oh, sorry, not next week, tomorrow. Okay, so very crudely, we need a few things, right? We need the model package, like the weights, the config files, the tokenizer files, basically everything the model learned in pre-training, which is here in Hugging Face. It's kind of the standard for downloading these open weight models. Once we have the model weights and the files, we need somewhere to store the weights and files. I don't want to store them on my computer. So for that, we're going to use modal volumes, which we'll talk a little bit about. It's just like persistent storage for the weights and the model files. And then we obviously need the GPU or the hardware to run the model. So we're going to use the A10G, I think it is. I hope I got that right. Seems like it's kind of the right GPU for to run this Qwen model. Yeah. So and then from my understanding, the license here is pretty open. I should probably check that, but I think you can use it for whatever. So yeah, the Qwen 4B instruct using the A10G. I hope I pronounced that right. GPU through Modal. And then we need some kind of inference engine, something to bridge some software to bridge the weights with the actual GPU where we want the computation to happen. For that, we're going to use VLLM, but that's kind of baked into. It's really easy to do this through Modal, which I'll explain in a minute. So again, just to emphasize, like there's different ways to do this. I'm just using this type of abstraction for the reasons I explained in the first video. I've got a shitload of Modal credits. I am learning how to do this. So Modal's kind of nice because I can see what's happening, but at the same time it's abstracting away kind of the heavier complexity that I don't really have the hardware or knowledge to do. So if you just want to test like an open weight model for yourself, the best thing to do is probably use something like Ollama, and then use one of the Gemma. The small Gemma models are really good. Small Gemma, the Gemini open source model, And you can get that up and running really super quick on your local device. Like a decent laptop would be able to do that. We're going to use kind of this middle ground abstraction, which is to download the model weights. I want to download the model weights to my computer so I can see them, and then upload them to a modal volume, and then just so I kind of get an idea of how it works. So yeah, different horses, different courses. So yeah, I kind of had to go back and unpack how this worked, because I realized I didn't really have any idea of what was happening under the hood. I think it kind of makes sense to have at least a very basic idea of how things work without the abstraction, so you know what you're abstracting over. So if you were to go like kind of full raw dog, you would have to buy a GPU, or I guess rent a GPU from Amazon. You have to install the required software and services, the drivers, and the related software. You need to install the inference library, which we're kind of doing anyway. You'd install it locally, load the weights onto the GPU, and then you would also have to run your own inference. And you would do that. You would download the model weights in the same way we're downloading the model weights. So that's kind of how it works. If you were to do things locally, obviously with Modal's going to abstract away a lot of this stuff. So I can basically, rather than have the weights stored on my computer, I can upload the weights to Modal, into Modal volumes, and then Modal's going to help me bridge the weights with the GPU that I choose. And I can show you the code for that in just a minute. And so Modal's going to spin up a container for me, and in that container, I can select and I can select my preference of GPU. It's going to install all the software, the NVIDIA drivers, the CUDA toolkit, all that stuff. And I can also easily install the inference library, the VLLM thing that we spoke about, and then load my model onto the GPU and run inference. So that's what we're going to try and do. So jump back here into the project. Again, as I said in the last video, I kind of explained the project setup and how we have these different scripts for the different coding agents to use. I'm using Claude Code and Codex, and then what's it called, Droid as well. So this is the plan that we hashed out. We went back and forth on for a little bit, quite a bit, a long bit. Let's look at these steps. So as part of these templates that I create here with the coding agents, I try to get like a high level overview first of all, and then I flesh out each of those ideas. And then I go back and forth to make sure that I understand each of the steps. So step one, pretty self-explanatory. I'm going to set up the environment. Step two, connecting to the services. So this is all CLI. Modal makes it super easy. I don't know exactly how this works, but you basically can just connect straight through to your Modal account, and then makes a persistent connection there. You don't even have to set any variables locally, which is nice. And then additionally, I don't even know if you need to log into Hugging Face to download the model weights, because Qwen is open and free, but we'll go through that here. And then we're uploading to Modal volumes, uploading the weights, and then we're just going to check that it worked. So let's start here. Step one, step two, connect to the services, download the model. Great. So this allows me to download the weights directly here into my local project here. And so this is where you'll see the weights. These three files here, these safe tensors, these are the weights. This is getting a little bit out of my pay grade, but I'm assuming that this is kind of the standard for model weights. It's split into three. I guess it's kind of a way for them to shard the entire weights, because they're too big, into, I guess, more suitable sizes for upload. And then you got the tokenizer, which is obviously taking text, converting it into tokens, so it can be fed into the model once it's uploaded onto the GPU. Also, I understand I might be, if you have a lot of software engineering experience, I might be saying some things here that aren't so technically precise. So feel free to skip ahead if you're comfortable with this part. So model weights, config file, tokenizer. This command here pulls in the stuff that you need. I think I stripped this template directly from Modal's documentation. They got really good documentation. So I've downloaded the weights and I've downloaded the model here. And now I want to upload to the Modal storage. So from my relatively limited research here, Modal volumes are just like persistent storage. And it's nice because it's easy then to connect the weights with the GPU that you want to run. I don't know how much it costs. I think it's super cheap. I'd have to check the actual price, but I think it's like pennies on the month to store, like relatively small model. Okay, great. So this is super easy to upload the weights directly to Modal. I think it took like maybe 10 minutes. And then once the weights are in the volume, you can actually come here. I'll just go back to the dashboard here and storage and Qwen model volume. So yeah, all of my model weights now live here. And now I can directly specify this folder for the weights. Nice. So this is the part that I had to kind of backwards work out. What am I trying to say here? To reverse engineer how this worked. So this, again, I think this was a template I started with from the Modal documentation page. This is basically the script that you're going to create to build the Modal app. The Modal app is going to be like the Qwen model that I'm going to use and the GPU. So going through this here, I'm going to do my best to explain it. Obviously, you might want to review the Modal documentation. I mean, you'll definitely want to review the Modal documentation. Here we're specifying the model. This is what's going to set up the application in Modal, and then this is going to reference the weights that we just uploaded and the model files that we just uploaded. This is going to set up the container, the environment. It's going to import the required NVIDIA software to be able to run the GPU, and PyTorch to do the math. And then down here, these installations, VLLM is the inference machine that we spoke about earlier. I think I have VLLM here. It's basically what's going to, I guess, kind of bridge the weights into the GPU to be able to run the computation when we start inference. And then here I'm specifying the GPU. Timeout, I'm guessing that means it's going to run every 20. It's going to stay live for 20 minutes. And then what else here? The VLLM command is going to run the inference service. So yeah, I'm not going to go too much into explaining inference, but this is basically the process that enables the model, the tokenization to process and to happen, where we can prompt, or the students for my use case are going to be able to send their queries. Queries are going to be converted into tokens. Tokens are going to be fed into the weights, and then the response is going to be generated. All right, so that's it for the script. So once you've run that, you can come back to Modal, and you will be able to see the application now living in Modal. I think it just stays there, right? And then Modal will somehow, I guess, spawn the GPU when it's being used. Otherwise, it's probably switched off. I have to check how that all works, to be honest. So here it is here. This is the service that was created and the GPU. And then once you've got that live and running, you can test it. So if I come back to here, I'm going to my prompt here. What is the capital of France? Stupid, offensive, or incorrect answers only. And so now I should be able to actually see that working in Modal. Yeah, we can see pending here. And so I guess it's firing up the GPU. If this was, this is outside 20 minutes, so it's going to take a little bit of time. I don't really understand fully how the cold start mechanism works, or if it's going to work this way if I've uploaded the weights to the volume. It's something else I would need to look into. And then I guess I can check here, like, it's super cost efficient. I've been screwing around with this for like a week and I've spent $12. So that's still running now. All right, worked. I'm sorry, but I can't provide stupid, offensive, or incorrect answers. That's a bit lame. The capital of France is Paris. Great, so got that working. The next one I promised to try and do live. We're going to start with the vector store. So we're also going to be storing the Chroma database as, or in the Modal volume, and then we can start trying to integrate some kind of retrieval system.